Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this to December 10, 2021, Friday, and this is 3:45 in morning, 3:45 a.m. नमस्कार. मैं सूरज सिंह सिविल भारत इंडिया देश से बोल रहा हूँ. आज दिसंबर 10, 2021 सुबह के 3:46. Presentation to you about same talk as usual in continuation previous one. And this is regarding same issue, civil field engineering, life engineers, concrete specifications. I have added to that because I am also interested in dissemination of concrete, what concrete is. And therefore, quality is related to that. AnnexSL, of course, that is system, quality system, structure, and of course contract books like red, silver, white, references to those, and safety. Of course, design, construction, methods, contracts, and of course certain disputes because contracts are related to those. And whatever organizations, communication, coordination I'm talking of. So you can say many issues are there, बहुत सारे issues हमें मिल रहे हैं. You can see that first of all it is engineering which has nothing to do except with life, means engineering cannot work independently, there is no life and life cannot move without engineering. And engineers, of course, are involved because engineers are instruments. Engineers, you can say mechanism. Engineers is a person. And engineer is also so many issues. You can say engineer what can be used at many locations. And everybody can use it if you do engineering. Means if you use as a verb, engineer, it's okay, fine. Concrete specifications, which are very important because concrete is a major part of construction. And you can see you live in a construction of concrete all over. In this era, concrete is very important material, significant material, and we all use it directly or indirectly. We may not recognize that, but we use it. In structures, concrete is indispensable. You cannot say, I can't do concrete because I am going to use an hutment. That time has gone. Adobe is not available. Adobe is no use. Means you cannot say, I have Adobe hutments and I'm using in that, I'm living in that. There's no way. So concrete specification should be known to everybody, not only to engineers but also to people, other people, because they are unaware of that. And concrete is solid material, is long-term material, is durable material, and without it life can't move. You have to see this point. And quality is, of course, quality has relation to material, and quality has relation to system, and quality has relation to human being, and quality has relation to society, and every you can say belong we use in different. Quality itself is related to nature, and nature knows quality. It has given quality when you observe only from nature, as we have science and engineering. And we can say AnnexSL, which is structure, high level structure in system. You can say ISO 9000 or whatever else system is organized, and we have to follow that, or we have to understand that, or we have to establish our own system. And of course, there are systems, and we have to deal with that, and we have to understand in reference to this quality, because every topic is interconnected. Now, no topic can be, you cannot say this is in isolation to other topics. And there is red book which is called construction contract, silver that's called you can say EPC contract, and white that's called consultancy contract, and maybe yellow and others in SHE, safety, health and environment, and we can say designs and construction as part of engineering, which is part of life. And methods are important issues because without knowing methods you can't do anything. Whatever you want to do also, you have to somehow methods, so only then you can do. Even if you don't formally recognize it, you don't formally write it, use it. Methods are methods and contracts are contracts. Without contract, what can be done? And we have to license. So we cannot abuse this for contract. So contract it is, and contractor it is a very bad person, it is a very corrupt person. It is. That is maybe a conventional thinking, but important fact is without contracts, you have to move on a track. Two person have to move on a track, just like the wheels of a rail, wheels of a train or car. They have to move together. Two wheels are necessary, otherwise vehicle can't move. More than two maybe, but it's two on one. Only scooter can move, or bike can move, cycle can move. But when you want a real balanced vehicle, you have to have two wheels. Couple, you can say. Contract is a kind of couple. And then there may be contracts and there may be disputes as well, because there is a contract, there are conditions, there are disputes, and of course organizations, bodies, corporates, or you can say. Then another point is communication coordination, which is very important from every point of view. That's why I'm just trying to give you. And then we can say, of course, certifications. Certifications are very, you can say, instruments. You should say these are instruments, legal instruments. That person has certain capability, that person can be relied upon, and that's where you can say something happens. And you can say then concrete, of course. Without concrete, as I said, we can't move. We can't move. We can't move in development. It's a part of development. So we have to be very clear about our introduction, what I'm talking of, because it's really significant to know. And I just IP certification, and this is membership. Communication, coordination, and quality deliberation file that I use generally. And as I said, communication and coordination are very significant words. संचार और तालमेल, संतुलन का बनाया होना उतने ही महत्वपूर्ण है जिसके बिना हम आगे नहीं चल सकते. वी कैन नॉट गो अहेड. आपको आगे चलने के लिए इनको समझना होगा. आज नहीं लोग समझते, ऐसा भी है. और ये मेरा एड्रेस है आपके लिए, ईमेल एड्रेस suraj_engineer, you can say SURAJ, suraj_engineer@yahoo.co.uk. Don't write com, it is co.uk. By chance it is Ireland's website, no problem. You can send to me mail, and of course I have given my contact number, but better but you can say that I want to talk, or why don't you send email when it is available. I can read whatever time and then respond to that. If it is good, if you want, if you say no, this person is useless, no problem, thank you very much also in that case, because everybody has a right to think that some person is useless, so I may be useless for you, no issue to me. I want to help people, I want to give back to world what I learned from world, and that is duty of everybody. And this is quality file, as I said. Again I say, I remind, documentation is very important. If you don't document something, means there can be no reference to that. Documentation, written document is a must for reference. That is, cannot be, that this fact cannot be declined or defied with. And excessive use of mobile stops our life, you can say. If I use excessively my mobile phone, or you use your mobile phone redundantly, you can say, rather saying redundantly means more than required, redundant is more than required, you know that. Why to use more than required when you have no time, when you are too busy and you can't record anything documentarily? You say one sentence 10 times, or you give one instruction 10 times. What does it mean? Shall that person understand more better? No. It's only reiteration that you speak, and there's no direction, there's no advice, nothing, and you have no confidence. That's why you say again and again, and that person listens to you again and again. And of course we deal with engineering, and engineering is such a world where pointed requirement is necessary, precise requirement is necessary, and also explanatory description is necessary. For purpose of communication, we have to write specifications, and that are very important. Specification doesn't mean it applies everywhere actually, but when we say in engineering, it is technical specification. It's not normal one. Means we are going to use material, we go to use material, and we spend money on that. We use human resources and equipment, and we use them, and there is no sense if you waste them. If I waste my material, my presence of money, human resources, then I call myself mindless person. Because if I am qualified one, if I have capacity to do something, why to waste material? Why need to make better use of such resources which we have? And that's also a kind of, you can say, quality performance. Quality performance doesn't mean actually just to have product quality, but to also it's also required that we should get efficiency in working, because efficiency means production, speed, and if that speed is well supported by quality involvement, I think there can be nothing better than that. In systems they say you can so many errors can be accepted, so many millions. That is theoretical. Actually it happens that in construction engineering, in civil engineering, and many other branches of engineering, errors do happen and we try to hide them. For example, even in safety engineering, safety arrangements on site, we try to hide and we say we have worked for so many million hours without accidents. Can you believe that? We know this is fabrication. Accidents do happen when people work. It happens. Of course, they may say these are not fatal. Fatal or non fatal, accidents are accidents. Errors or no errors. Errors are errors, and we have to accept that. Why to show unknown standards, or you can say fake standards? So we can say we have to depend on certain design and certain specifications, and design specifying engineer is very important, because design is not easy. We can say design is like research innovation, or you can say it is research during operation. One time you design same topic, another time same you can say same article, another time you design this slab, then you design after 3 4 days same slab. There shall be some difference. It happens because some new points come into mind, or you can say some error can be detected. It happens because design it is for others, you think so, and of course your mind is a smart one. So there can be many trial and errors, and during design itself you start with something and then you change it, and you can say convert it to something else. It happens. Or you may have entirely different concept. We can say it's alternative design. If I say you have to understand and you have to make other understand also. Other understand means responsibility of design specifying engineer to include demanded technical activity. What is required, that's important, and technical activity means it's based on procedures and formulas and theory and analysis. It doesn't just based on one thinking. There are so many points that are considered. Of course, we have software these days, but when there was no software, people used to best designs, better designs, and of course you can see evidences of that in past constructed structures. And I find now when everything is available, quality of structures has been falling. Unfortunately, people are more interested on software and sitting on computers rather than involving on real work. Engineering is real work, in fact. Engineering is real work in field. It's not work on computers. So yes, computers is support without which you cannot cannot move, we cannot do anything, we cannot, you can say, give efficiency. But we have to realize also that capacity of mind that required to be used on these designs and analysis, that capacity has gone to computers, and we can say coefficient of confidence has come down. When we use when we use designs preliminary or manually in those days, or you could call them by calculations using calculator, otherwise there was a highest degree of confidence because we used to have clear idea. I'm going to you can say, if I assume this was okay, this used to be okay. And that was a degree of confidence that your mind identified what it should be and it proposed that into yourself. And now it doesn't happen because you don't have that experience, and you try, you can say multiple tries. And why try multiple? Why don't you have confidence in yourself? If you have experience, if you have knowledge, I don't think you need so many trials. Well, I'm not against that. You try, but point is that idea is a must. Some intelligent engineer, experienced engineer, instructed others during some seminar that try to understand behaviors or conduct of a constructed structure. So let us say it is constructed. though it's not constructed, you have to imagine that it is constructed. And when it is constructed in your conception, you have to think about that. You have to talk to that structure so that the structure responds onto your questions and onto your assumptions. And those points are very significant. You cannot simply say, I don't have a structure. You have not to talk in that way. You can say in verbatim, but in imagination, you have to see how can this structure perform. Not necessary that whatever others says or what a book says, that's valid. You can say it can perform this way or it can perform that way. Both ways are possible, because who knows actual behavior? Nobody knows. Uh, who knows how a seismic action is going to impact on this structure, or how when it's a high rise, or how actually storm impact on this, or how solar thermal energy impact on this. Means there is theory for every article, for every point, but that is for purpose of detailed verification. But our point is conception. When we say we conceive something, we deliberate something, and we are qualified people. We can understand, we have common sense. I still remember my one of professors used to say, civil engineering is based on absolute common sense. Construction is based on common sense, and common sense cannot be purchased. Common sense cannot be inculcated into mind by certain professor. Common sense is your own sense. It is like a God gift, you can say. God has given you mind, and in that mind you have certain good soul, and your soul is so efficient that it gives you, tells you silently what you have to do. And that's why we say, I think like this. I consider like this. We say that. This means my soul helps me, but I don't realize that fact. It can help me directly, it can help me through intuition, it can help me through dreams, it can help you whatever way. If mind says during work itself, oh no, something is wrong somewhere, and I have to edit it or check it. I have to examine my own work. It happens. It doesn't mean I have something, it is something in me, and that is what I'm talking about. It's soul, or it's electrical circuit in your mind, or it's your own way. Same way when you design some structure. You design some structure for construction. We have something in our mind which you don't realize, and that something in mind is not automatically born. It comes through innate power. It comes through some power within everyone. This fact we have to connect. I mean, it's not, you can say it's soul engineering or spiritual engineering. Spiritual exists, spirit exists. You cannot say no. When compression force exists, tension force exists, shear force exists, or you can say torsion exists, or sway exists, of course there is force, and that is soul force. Energy from soul, energy from spirit. If your compression force is there, why can't you say soul force also exists? And that is in mind. We say his mind is very brilliant, he is a mind, he is a brilliant. We say that. What is that brilliant? This means comparative energy of soul in one person is more than other person, or it is much more than person. Those people who write books, they cannot write in one day, and how many times they edit that. You have to understand that point. When we used to write using pen or pencil, there was no type worker, there's no typewriters. How could they write that? How many times would they have changed that? That's what I say. Today writing is not a problem, but sense of writing is a problem. People say, oh, they write using computer, keyboard. It is physical means. Computer use, or you can say keyboard use. It's not writing. It's only tool. Writing is mind. What your mind says, you have to write. What do you think? What you interview others, what you extract from that, that what is reflect. That is writing. That sense is writing. It's not, computer cannot write. No computer can write without data input. How can you say if computer does not have program, it can write? This is the program is writing, it's not computer. That's why I always stress, I'm not saying you don't understand this. Everybody understands what I say, but it is just refreshing or just a kind of review because we forget. Everybody has a habit to forget. And as much as you advance, you forget higher and higher. You forget more and more, you can say. When you are kid, you are infant, you are in school, memory is very high, remains very high. Because mind is free, full use of mind is not conducted. Child plays, child enjoys life, and child studies for some hours, either in school or at home. And that is also, you can say, not very complicated study. You can say entertaining study, and they understand. But memory power is more in that kid, and that's why they can remember by cramming. You see, every child can speak something, can write something, but when you analyze something, ask at random, that child does not respond. It happens. I ask many kids about tables. In Hindi we call it pahada. They will speak, they will, if you ask them, show me, tell me how, or announce me, or narrate, they will speak all. But when you question them, what is value of this, then I think every child stops. This is what child is and where matured is. A thinking power of a matured person should be much more than multiple times than power of a kid. Power and memory power of a kid is always better, much better than power of a matured, because as matured you are, as aged you are, as much as you are senior, your mind remains very active, your mind remains very busy. This means majority of, you can say, memory cells in your mind do not work, but quality cells or performing cells of mind work. Your mind remains busy all day, active, so that memory cells cannot come up, but when your mind goes back to rest, then those cells come up, and at random you think, oh, I could not remember that time in day, somebody asked me this, now I got this happens. So don't worry about that. It is work of mind. This is in control of none. Nobody can control it. Only you can control your mind. And if mind is controlled, means system is controlled. Body is ruled by mind, everybody knows. So I have to keep my mind purely right and receptive for every work, every instruction, or what I have to instruct others. And therefore I say, when we work on sites, we are very busy. Everybody remains busy. Of course, we have to follow systems. we have certain supports also on site. But you see, everybody is not dedicated, not devoted, and not, you can say, committed. Percentage of commitment varies in every person, from person to person. Some people are very strict in their control, on control, and others do not control themselves. So they are controlled by others, and those who have to control them, they are also same. So there can be nothing, you can say, I think. So what I want to confine back to quality, this is also part of equality. How do you conduct yourself? How do you conduct with others, and how others conduct with you? Because it is not one person who has to work in construction. It's not alone design. It's not something you have to write a book or you have to write something for others. It is work that we have to do, and it depends on how many persons are there in a work and how competent are they. Sometimes people are very competent. All classes of people are very competent on a project, and project runs very fine in time and with quality, and sometimes it is reverse, that there is nothing that people understand and they do their way and project goes to woods, you can say. So what we have to understand is that during construction there should be quality controls, quality criteria must be applied, and we do that if we are okay, if there is some good supervision, there is some control, and of course in production it happens, in manufacturing also, if system is okay, it is well designed and operative, and it may be services or education, but question is education, because in education it is different world, there is no professionalism, to be very fact. It's only teaching, and teaching is a much more profession, much more powerful profession if it is understood. But there is a confinement that you have to teach within syllabus, and a student has a confinement of his own, that why should I study more than this when I can qualify this examination? Means learning point misses somewhere. Education is for purpose of learning. Objective of education is to learn more and more as much as possible for purpose of use in life, but its only target is only qualifying examination, and that reduces value of education. Of course, it is necessary that you have to pass examination, but that examination says that person knows everything, but in fact you know only for target of examination, but not for use in life. And that's why when we are examined, we pass, but after examination is over and results are declared, we forget everything. This means it was not well programmed. Education is not inculcated as a programmed software. You have to study again, you have to open books and see, I studied that one. Sometimes you remember that, okay, I can, maybe you take lesser time this time to comprehend that chapter when you took more time at time examination. And that's why the society can be considered as educated or illiterate based on this. If I have good education, but I can't apply that, I can't refer to that, only it's for purpose of job or it's purpose of some passing examination, that is different. But when you say it is engineering education or it's medical education, which are very, very practical, medical science and engineering science, these are different type of sciences which cannot work without knowledge, without application of knowledge, without application of theory, without application of analysis. Or you can say engineering applications. In fact, there are so many ways we can define engineering, and say there are so many ways medical science can be defined. But other professions are linked to these professions. If engineering and medical science do not exist, there is no requirement of any other profession, because engineering is related to industry, engineering is related to production, engineering is related to construction. And if these fields are missed, so just imagine if there is no field in construction, there is no field in manufacturing or industry, where shall we stay? What shall economy do? What shall society do? And what shall be development of individual, management or others, or commerce or chartered accountancy or all law, or all will go to dust. So we can say engineering and medical sciences in fact are dust free. They create dust, but they are dust free in themselves. These sciences are dust free. They are creative and useful sciences, and whatever within these, and we can say ultimately we have to know all these through one another. And that's why we can say quality in word of, you can say in domain of communication and coordination are very much considerable. And if you don't have that, if you don't have communication and qualification, I mean to say coordination power, which actually people do not realize, we cannot do anything. Even I can't study further. I can't solve any problem. It may be engineering problem or otherwise. No problem is independent of many factors. There is no one factor that only dominate, or can say dictates one problem. There may be one problem, there may be many problems, and there will be multiplex of factors that come into its play. We have to really understand that point. And we can say it's not only engineering where quality is required. Quality is required everywhere, in every activity in life. It may be whatever sort of activity. And of course, in engineering is quality system. In fact, you can say engineering itself is quality system. We may not say that it's not. It's a fact. Engineering itself is a quality education. And engineering is education not only through degrees, it's a kind of practical education throughout life. When we do work, in whatever way, in designs or in field or in research, it is quality system that we develop. Quality system. A system we develop means how better we can do, how best we can use this material, how best we can convert it to something else, if we think. So that is systemize whole world. You can say we systemize whole world through engineering. And engineering is actually, to be frank, it's something related to nature. And if something is related to nature, means something is related to superpower. That's we say God. So you may say engineering is God power. It is power that cannot be done in one attempt. It cannot be done throughout life. It is so powerful, so much powerful, that we cannot even understand whole engineering in this lifetime. Engineering is one word, but there are so many sub words in this with many fields. Every field, destructive field or non-destructive field, people are more interested in destructive field rather than constructive field, because destruction is heroic while construction is not heroic. It is very much struggling, it is very much hard, it's very much time consuming, it's very much, you can say, you have to devote your life, you have to do everything. But construction is a result of that, development is a result of that, and which nobody realizes because of so many issues of credit or no credit. People are not given credit. Those who are not due for credit, they get credit. It happens. But my objective is not credit. My objective is quality. Quality is something that we have to redefine. It's not what we used to understand only for testing. It is something not even for system. It is for whole world. Just imagine this planetary system, how this system has been working. Can you imagine how stable it has been? It has been working for how many years? We do not know, but it is working. All moment it is working. It cannot stop even for a fraction of a second. Can you imagine life like that? No planet can stop, no planet can change its route. And if it changes route, it can fall. Can it fall? Did it ever fall? This point should be contemplated. It is not a question of education, it is a question of natural understanding. Can I understand nature? Nature is my teacher. How efficient does it work? How fast does it work? Can it change its course of action? And how it is so all time remains, how it's in equilibrium, how does it remain in equilibrium? And it has never collided with, it is a planet. Planets, no planet collides with other. This means there is much behind this engineering of nature. We don't understand engineering, in fact, to be very frank. Our engineering is very, very low profile. We are sitting on earth, we are staying on earth, and we think everything is this, and we know everything. Just can imagine very, very common sense point of sun, performance of sun. How does sun perform? We say, we know what I mean and what you mean, but how does it perform? If one planet illumines all planets, all solar system for certain hours, and all, if you combine all network of electrical system throughout world, you cannot get equivalence to power that sun delivers. All power stations, how many thousands and lakhs of power stations of whole world are connected together. You cannot get illumination equivalent to what sun provides. Is it not a question to contemplate? There is nothing, we have no involvement in sun work, and we get supplies for so many hours continuously without paying any bill. And that's what I say. We cannot, I can say, ignore these points. You may like solar energy, heat, or may not like it, but it is a fact. It's a fact that at night you cannot illumine even, you can say, 1 kilometer of space. Your flights fly at a point, say 10 kilometers. There's a darkness everywhere. Same way, if you don't provide, you don't have that much capacity. You cannot convert night into day by artificiality. Engineering has not that much capacity still that create day in night time. No way. We have to understand such facts. This is, of course, not directly related to engineering, but indirectly it is related that we should understand engineering is not that much advanced till now, and science is also not that much expanded that can reach sun. We cannot even know speed of with which this earth revolves around sun, orbits around sun. How many of you do know that? I think you will not answer that, except maybe one or two persons are there who might have such conception, but in fact it doesn't. So we can say quality required everywhere and in every activity in life, and in engineering, life is engineering based, and this fact cannot be denied or condemned. And also, which means that engineering is domain of super life, and profession like medical is domain of super profession. Engineering, you cannot simply you can combat it under title of profession, because profession means it indicates something that you have to live on about, means you have to earn money, while profession doesn't mean that. Profession has got many meanings, and what I understand is you say this person professes this religion, this person professes that religion. There also we say profess. This means engineering is not a profession of that sort that you have to earn and make your livings. That is basics part, of course, but engineering is a kind of faith, it's a kind of reliability, it's a kind of that you procure trust in yourself. It means say engineering is a importance of trust. It's kind of something you import from other countries, and engineering a kind of understanding, it's a kind of knowledge, it's a kind of field that you import ideas, and this is ideology. This is something that mind connects to you if you are not so much smart. Education purpose is that to analyze every issue, to analyze every part of life, and then apply your answer onto that, and then again answer in a better form. So every time quality changes, and of course factor of safety changes. That's why we have to understand that we are not perfect. We are not perfect like nature, and we can't be. This is just for explanation purpose that I want to involve myself for what I think. I'm not saying I know everything. I'm a very small person. You may be much knowledgeable in comparison to me, but it is just sharing of ideas, what I think, what I have moved my life. How have you moved your life? And now what I think, what I used to think before, it differs. But engineering doesn't change, thinking doesn't change. Specifications, as I said, don't take more time on this, and we in our you can say concrete, as I said, we have to understand this. Last time we said water, we did, I think we did water testing, etc., and we were somewhere, I think we were somewhere, no, we are here in testing and samples, pH of water, quality of water, water journal, and we are somewhere else. Materials, we were somewhere there. Aggregate wagons, cementitious materials, and yes, cementitious materials. If we go through that, I don't actually remember. It was somewhere there. You can say, where is water has come again? How is this done? I think the water. No? Supply and storage. And it is chloride, Methods++ concrete. Then it is admixtures. I remember admixtures we did. admixtures we did. What to prepare mixtures? Inorganic, organic. Yes, we did inorganic corrosion inhibitors. Yes, I remember now. We reached inorganic corrosion inhibitor. This calcium nitrite. It was no. It's also property requirements we're talking. All these you can see. Yes, here we are on this codes list we have gone through, and it's now definitions. Yes, we were here page 37, and we were here in definitions. So now we come back to our world of quality of specifications. Means quality basics. Actually, we cannot deny this fact, and here we say in, of course, contracts are related. Contracts and specifications are related. If there is no contract, then you can say there is no specification, because contractor has to work according to specifications. And when there is a contract, even it is construction contract, or it is engineering procurement contract, engineering procurement construction contract, or it is, you can say, even supervising contract, whatever contract does exist there for whatever project, we can say specifications are involved. If it is design project, then you have to select specifications and apply onto that the documents, or you have to define your own specifications. We can call them particular specifications. And when you say no, it is general specifications already available, we have to just extract that or refer to that one. That can be called general specifications, and every country has got its specifications. Of course, means there is no major difference in this. Almost all specifications are same, with certain, just like all codes are same with certain differences. Specifications also like working code. You can say it's up to engineers to decide how this work shall be done. But engineer is not, it doesn't decide based on, it's a preliminary work, it designed based on certain, whatever is, all the properties are known. Some systems, within systems have been defined, and those are technical systems because of testing, because of research, because of conclusions is so far. We use those, and nobody is perfect in anything. So these systems of specifications is actually written quality domain. And if you don't comply with specifications on whatever work, it can be said that you did not comply with the contract, and therefore this is not quality work. Compliance on contract is also a part of quality work. And how do we reach contract? How do we design contract? That is a major part. Designing contract is not easy. Designing specifications is not easy. We can understand contract, we can read contract, we can examine whether or not contract conditions have been complied with. But contract conditions, like we can say reference to FIDIC, or before that reference to something else, or reference to national standards of our contract, or we have this contract which also includes how shall we care about these conditions financially, technically, and commercially. This happens same way. This is, you can say, specifications of all materials, specifications of whatever we are going to include on project, temporary or permanent. Temporary are generally considered to be related, you can say, confined to safety and efficiency, whereas as far as for permanent works are concerned, these are projects, you can say, specifications of materials, specifications, everything that should be complied with, that should be, you can say, carried out accurately. And that's where we say this is specification. But every such specification and every such design of specifications, or you can say specifying itself, generally be called specifier, because specifier selects the specifications, or writes its own specification, just like a specification manufacturers give, that cannot be found in whatever notes or books. These are different because those are research based results. Those specifications where you can say manufacturers are professional one. They are not just manufacturer for copying something or repeating something. they research on that and they take responsibility as well, provided conditions enumerated by them are complied with. When there is control beyond their controls, they simply say, we are not responsible if you are not going to use within these conditions when subject to these requirements. Manufacturer shall not be responsible. And that's what simply it is said. And that's not trying also, because there's some temperature correction, there's some temperature involvement, some time involvement, something else is there, because it is a specific material. They manufacture that material within those restrictions you have to use, and if you don't use, then it will not perform. But if you keep those materialistic conditions as enumerated or given on data sheet, that must be maintained. So they say it works, and that's what they say. So you can say it's a kind of specification which is manufacturers based, and generally it's written that you have to use those materials which are manufacturer based, and those instructions you have to follow. And if you don't follow those instructions, means that's a point which is, you can say, integrated in a method statement, that manufacturer's instructions shall be followed. And of course then research based specifications. Likewise, we are seeing now, this is a file of concrete specifications, and it says, I think 2000, I don't know exactly what it is, but it is specifications of concrete. These are from state of Qatar, nation Qatar, but doesn't matter, it is Qatar, no Qatar. It is of course concrete specification, and that's very important. And of course these are updated every few years because of advancement in technology, and that's a good one. Means why not to update? And I cannot say this is perfect one. I cannot say that. But I believe I experienced, it's experience based, that which I did or which I may do, or others also are there. I have seen specifications from Gulf countries like UAE, Abu Dhabi, from, you can say, Qatar, and of course we have seen specification in codal forms, and we have seen various other specifications. Almost everybody, uses each other's specification. You can say I have seen ADNOC, Abu Dhabi National Oil Company specifications. Then we have seen other specifications. I have seen Qatar civil construction specifications. We used to call that sometimes QNBS when I was there, Qatar National Building Specification. Then it converted to Qatar civil specifications. Likewise, we have many specifications in our country as well, long back. I don't know what status now. But this way or that way, it doesn't matter, as far as we have to think of quality results, quality performance, and that's where it is. So I gone through many points on this, and we were this is a page, for example, 613 in this file, its definitions, and it gives exposure conditions that apply in concrete. And how does it work? It says there are class X0. Something is given in something, you can say, for example, class X0, X0. This is no risk of corrosion or attack. There is no corrosion in that area. There is no attack of corrosion, and there is no saline conditions, means no sea, and there may be no salts in air. So you can say blinding concrete, non-reinforced concrete, or slab on ground. You can say if you use concrete in blinding, or where there is no reinforcement, or say ordinary slab on ground, you can call this class X0. X0, you can say concrete on ground, non-saline, blinding, and no risk of corrosion. Then you can say another class is class X1, which is, you can say, upgrade this, and from 0 we bring it to 1, and it is mild exposure of non-saline conditions, mild exposure of risk, you can say, mild exposure of corrosion, mild non-saline conditions, and it may be dry or wet, rarely dry, it's always wet. External concrete at least 3 meters above ground level. You can say 1 story, you can say external concrete a story up to 1 meter, or 1 story 3 meters above ground level. This is internal concrete in dry conditions, concrete permanently submerged in non-saline water, or non-aggressive groundwater. So this is class X1. So you can say we can go to next one, and that is X2, and moderate exposure. So it was mild, then it becomes moderate. So you can say in graph you can take first no risk, then mild risk, and then moderate risk. So it is moderate exposure. Of course, non-saline conditions, sometimes wet and sometimes dry, cyclic wet and dry. External reinforced concrete. It was internal before, now external it was up to 3 meters above ground, and you can say now it is external concrete, external reinforced concrete less than 3 meters above ground level. Water retaining structure is there, exposed to fluctuating water levels. So water has come into play here, though it is less than 3 meters, but water changes every issue. So we can say moderate exposure, non-saline conditions, cyclic wet and dry, external reinforced concrete less than 3 meters above ground level, water retaining structures exposed to fluctuating water levels. Then we have class 3, X3. Let us see how does it say class X3. Aggregate exposure. Aggressive exposure. It is not moderate, it is fighting type, or it is non-responsive. I listen to me, it says like that, aggressive, what I am saying, it permanently submerged or wet. It's in water, you can say permanently, rarely dry, concrete in contact with groundwater. Concrete in contact with groundwater, including capillary rise zone, concrete containing or permanently exposed to saline water. So it is different condition. Severe exposure. Now it's on higher and higher movement. Severe exposure. This is moderate humidity, external concrete, humidity is external concrete within 1 kilometer from sea. So you can say catchment of sea, or in contact with high saline water table, or subcause and concrete not affected by condensation, irrigation or leakage, which are more than 3 meters above ground level. So X4 is, again I read, severe exposure, moderate humidity, external concrete within 1 kilometer from sea, and in contact with high saline water table if there is no sea, or subcause, concrete not affected by condensation, irrigation or leakage, which are more than 3 meters above ground level. Here is then class X5, which is extreme exposure, cyclic, wet and dry, external concrete within 1 kilometer from sea, or in contact with high saline groundwater, or subcause, concrete affected by condensation, irrigation or leakage, which are less than 3 meters above ground level, or within capillary zone, concrete surfaces exposed to sea water splash, or in sea water tidal zone. So this is class 5X5, extreme exposure, and then sulfate exposure classes S1 to S4. Sulfate exposure classes. Exposure classes are related to sulfate attack. Sulfate attack in relation to sulfate and pH of groundwater. So how many we have seen? We have six classes. Class X0, no risk or corrosion or attack. Class X1, mild exposure. Class 2, moderate exposure. Class 3, aggressive exposure. class 4 severe exposure and X5 extreme exposure, and in sulfate exposure class S1 to S4, and pH, sulfate and pH of ground. I think this is very easy to understand. We can analyze it further later on. I'm just going through what it is given further. And it says concrete is a mixture of cementitious materials. It's very basic, everything but better. Why not to read whole specification for better understanding, and particularly for those who are young, and of course public who has nothing to do with engineering, but they should know how it works. Concrete is a mixture of cementitious materials, coarse and fine aggregate, and water, with or without admixtures, which develops its properties by cement hydration. Very simple definition, beautiful. If somebody asks you to define concrete, you can define this in this specified or precise statement. I could not see even answer from many top people in engineering when I questioned this. Concrete is a mixture of cementitious materials. Now they are not saying cement materials, cementitious materials, coarse and fine aggregate, and water, with or without admixtures, which develops its properties by cement hydration. Means chemical processes, cement hydration, development of properties, expected properties or intended properties by cement hydration. And cementitious materials, what does it mean? Cementitious materials, it's also going to define in this specification that we have to care for. Cementitious specifications: Portland cement in combination, it's not alone Portland cement, Portland cement in combination with one or more following blended hydraulic cement, and this can be fly ash and other pozzolanas, ground granulated blast furnace slag, and silica fume, subject to compliance with requirements of this specification. So it said that cementitious materials can be defined as Portland cement in combination with other materials, which they call blended hydraulic cement. It can be then said, that is following blended hydraulic cement, fly ash, GGBS, and like pozzolanas there, GGBS, and silica fumes, and subject to compliance with requirements of this specification. Now it's a water cement ratio. Now it's not water cement, but cementitious ratio shall mean ratio between total weight of water in concrete, and that is less water absorbed by aggregate. Of course, there may be some aggregate, some quantity of moisture or water, and if you total weight of water and if you deduct that weight, that's actual weight. And weight of cementitious materials expressed in decimal fraction. Then we have admixture. How can it be defined? We can say admixture. My leg, my God, there's a problem with me. Long stretching is also a problem for me. Sorry, gentlemen, I'm telling you my problem. Don't take it otherwise by chance. I have said admixtures shall mean a material. Admixture shall mean a material other than water, aggregate, cementitious materials, or fiber reinforcement used as an ingredient of concrete or mortar. When I'm saying this is specifically saying admixture, this means something added to concrete other than ingredients. Concrete ingredients are water, aggregate, cementitious materials, or fiber reinforcement, and admixtures are added to these ingredients. So you can say used as an admixtures are added during mixing process of concrete to modify properties of concrete, mix in fresh or hardened state. So we can say admixtures are modifiers, in fact, to modify properties of concrete. Admixtures are not ingredients, these are modifiers, so that properties of concrete can be altered according to our requirement. that can be in either wet state or mixed state, or liquid state of concrete, or hardened state. So it says admixture shall mean a material other than water, aggregate, cementitious materials, or fiber reinforcement used as an ingredient of concrete or mortar. Admixtures are added during mixing process of concrete to modify properties of concrete mixed in fresh and or hardened state. Then we say hot weather. It's also something we have to understand, because hot weather is very much applicable to do concrete, and that's interesting one as well. Hot weather concrete or cold weather concrete, because there's a difference of temperature. Hot weather system, hot weather production and cold weather production both are different, because of high hydration process is to be completed. And every material has an impact of temperature, that also we have to realize. Hot weather means combination of these conditions, and this is that tends to impair quality of freshly mixed or hardened concrete. That tends to what? That tends to impair means separate, impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss. Moisture is lost faster with high speed, and rate of cement hydration or otherwise, causing detrimental results such as high ambient temperature when shade temperature remains above 40 degrees Celsius on a rising thermometer, 43 degrees Celsius on a falling thermometer. High concrete temperature, that is another point, high concrete temperature. Then low relative humidity, high concrete temperature, low relative humidity, high wind speed, and whenever the rate of evaporation exceeds 0.75 kilogram per meter square per hour. So this is limit. You can say 750 gram per meter square per hour. If that evaporation rate remains within this limit, it's okay. Otherwise, you can say evaporation exceeds 0.75 kilogram per meter square per hour. This is some point we have to take into consideration, being design engineer or being whatever site working engineer. So we define hot weather means combination of these conditions as given hereafter that tends to impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss and rate of cement hydration, or otherwise causing detrimental results such as high ambient temperature of concrete. That's not acceptable. When shade temperature is above 40 degrees Celsius on a rising thermometer and 43 degrees Celsius on a falling thermometer. High concrete temperature not acceptable. Low relative humidity, or you can say high wind speed, and whenever rate of evaporation exceeds 0.75 kilogram per meter square per hour. So then this is a good point, means we have to understand what is required, how does it work. Massive concrete, although it's mass concrete written, but sometimes people don't write clearly. You can say mass concrete is defined as whatever volume of concrete with dimensions large enough to require that measures be taken to cope with generation of heat from hydration of cement and attained volume change. to minimize cracking. Reinforce massive concrete structures include pile caps, transfer plates, structural members where least dimension exceeds 1.5 meter. See, here's the definition. I had used another definition in this which was more than 0.8 meter. So is given 1.5 meters, varying sizes, varying dimensions. Massive concrete is defined as volume of concrete with dimensions large enough to require measures to be taken to handle or cope with generation of heat from hydration of cement and attendant volume change to minimize cracking. Reinforcement massive concrete structures including like can say pile caps, transfer plates and structural members where least dimension exceeds 1.5 meters. We had 0.8 minimum and quantity 24 cubic meter. 8 cubic meter for thick members, and if it was above 8 meters it was considered massive. So you can say up to 8 cubic meters. Per my experience, I am just advising. Minimum size of member is 0.8 meter, not less than that. 0.8 meter and quantity up to 8 cubic meter can be considered thick member, whereas above quantity 8 cubic meter it can be considered massive member, massive concrete member. Then coarse aggregate shall be considered as that size passing 20 mm sieve, 20 mm sieve or larger sieve and predominantly retained on the 4 mm sieve. So you can say more than 4 mm can be said to be coarse aggregate, and then if it goes below, of course it is another one, and that is fine aggregate. So definition of coarse aggregate is that size passing 20 mm sieve and predominantly retained on 4 mm sieve. Fine aggregate is otherwise considered as predominantly passing 4 mm sieve and predominantly retained on 0.063 mm size sieve. So this is physical size range, particle size range, can say coarse aggregate and fine aggregate. Coarse aggregate is 20 mm and 4 mm range, and fine aggregate is below, you can say below 4 mm up to 0.063 mm. Now PC is a symbol or abbreviation which can be used for Portland cement, and also FA means fly ash, GGBS means ground granulated blast furnace slag, and SF means silica fume. Other names are condensed silica fume and micro silica. Gap graded aggregate. I'm taking this. It's cold. My God, why I did not take it before? I'm immersed in reading, so how could I do that? Well, gap graded aggregate means graded aggregate without one or more of intermediate sizes, and that is, let me say, hold on please, gap graded aggregate. Gap graded aggregate means graded aggregate, of course size graded, without one or more of intermediate sizes. So you can say gap, there is a gap of intermediate sizes, is graded aggregate without one or more of intermediate sizes is called gap graded aggregate. Single size aggregate means aggregates containing a major proportion of particles of one sieve size, and target mean strength, which means target mean strength means specified characteristic strength plus margin. Target mean strength means specified characteristic strength plus margin. Margin means difference between specified characteristic strength and target mean strength. So target mean strength and characteristics strength, there is a difference. That's margin means difference between specified characteristic strength and target mean strength. Acceptable or accepted shall mean acceptable or accepted by engineer. Engineer means engineer defined in contract, not otherwise. Not site engineer, not other engineer, but who is responsible for administration of contract, that engineer. Approval or approved means approval from engineer. Whatever approval we get from engineer, that is called approval or approved, no other approval. All in aggregate means materials composed of mixture of coarse and fine aggregate. Mixture of coarse and fine aggregate, and that is all in aggregate. Self-compacting concrete SCC. Concrete that is able to flow and consolidate under its own weight, completely fill formwork even in presence of dense reinforcement, whilst maintaining homogeneity and without need for whatever any additional compaction. So it is very simple, means no compaction or no vibration is required, is that type of concrete, or you can say self-compacting concrete that is able to flow and consolidate under its own weight, completely fill formwork even in presence of dense reinforcement, whilst maintaining homogeneity and without requirement of any additional compaction, and generally it is micro concrete. Procedural points that we go through, that contractor is about submittals. You can say what submittals are required, how these are required, how do we organize that, how do we manage. Of course signals are gone, but let me see, it continues. It happens every time, unfortunately. It's gone now. Contractors shall submit details of mixed designs to engineer. That is very much required. First step, that contractor shall submit details of mixed designs to engineer for approval. Material safety data sheet, that is MSDS, material safety data sheet, are equivalent for all products. Test results and other information as required to prove. Material safety data sheet are equivalent for all products. Test results and other information as required to prove compliance with specification shall be submitted to engineer for approval according to relevant sections of this specification, QCS, that is Qatar Civil Specification. So you can see your own specifications on at least following products. And what are those? These are cement, recent independent test results acceptable to engineer, confirming compliance with specified requirements and referenced standards. Manufacturers' certificates shall also be supplied for each batch of production of cement, or on a weekly basis, whichever is more frequent, certifying compliance with BSEN 197 or than early compressive strength of each and consignment. Early compressive strength of each consignment of cement conforming to requirement of these specifications at independent site laboratory, that is compressive strength of each consignment of cement at conforming to requirements of QCS part 3 at independent site laboratory. Deviation of more than 10% from either previous consignment value or rolling average shall be immediately reported to engineer. Testing at an independent laboratory shall be as ground granulated GGBS in abbreviated form, and it is ground granulated blast furnace slag. Recent independent test results acceptable to engineer confirming compliance with specified requirements and reference standards. Manufacturer's certificate with all information necessary to verify compliance shall also be supplied for each consignment of GGBS ground granulated blast furnace slag or on weekly basis, whichever is more frequent. Early compressive strength of each consignment of GGBS shall be determined in accordance with BS-EN 197 and BS-EN 15167 or ASTM 6C989 at independent site laboratory based on a blend of 50 by 50% GBS based on a blend of 50 by 50% 50-50 GGBS and CEM1. Deviation of more than 5% in strength from either previous consignment value or rolling average shall be immediately reported to engineer. So it says deviation of more than 5%, deviation of more than 5% in strength from either previous consignment value or rolling average shall be immediately reported to engineer. Testing at an independent laboratory shall be in accordance with BS per BS EN 197 as said before and BS EN 15167 standards and approved by engineer. Recent independent test results acceptable to engineer confirming compliance with specified requirements of BS EN 450 or ASTM 618. Recent independent test results. I am speaking sometimes again because signals are zero and maybe it's not recorded, you missed it. So recent independent test results acceptable to engineer confirming compliance with specified requirements of BSEN 1, BSN 450 or ASTM C1618. Manufacturer's certificates with all information necessary to verify compliance with internationally recognized standards shall also be supplied with each consignment of fly ash. Materials shall comply with this specification or QCS part 3 deviation of strength factor by more than 5% from either previous consignment value of rolling average shall be immediately reported to engineers. And technical organizer of premix company. Then we have silica fumes. Silica fumes, it was fly as we talk now. Silica fumes, I'm sorry, yes. Silica fumes, recent independent test results as usual, as in above. That is, recent independent test results acceptable to engineer, confirming compliance with specified requirements and reference standards. Manufacturer certificate with all information necessary to verify compliance with internationally recognized standards shall also be supplied with each consignment of silica fumes. Seven-day pozzolanic activity, 7-day pozzolanic activity test in accordance with these references BSEN 13632-631 or ASTM-C 1240 on each consignment of silica fume at independent site laboratory. Deviation of activity index by more than 5% from either previous consignment So because 7-day pozzolanic activity, 7 days pozzolanic activity test in accordance with these codes on each consignment of silica fumes at independent site laboratory, deviation of activity index by more than 5% from either previous consignment value or rolling average shall be immediately reported to engineer and technical manager of previous company. Now we come on to aggregate. Recent independent test results acceptable to engineer, confirming compliance with specified requirements and reference standards, and full details of proposed source of aggregate. Now, what are recent independent test results acceptable to engineer, confirming compliance with then mixed design, etc. So add mixtures, manufacturer technical specifications and recommendations, recent trial results acceptable to engineer, illustrating efficiencies of product for its particular application, tests on specific gravity and solid content. Solids content shall be conducted at independent site laboratory on each consignment. Mixed designs, submit concrete mixed designs for each type and strength of concrete required at least 30 days before placing concrete. New mixed designs with historic data, less than 6 months shall be verified by an approved independent testing laboratory in accordance with requirements of QCS Part 5 and when we submit complete mixed designs, new mixed designs with historic data less than 6 months shall be verified by an approved independent testing laboratory in accordance with the requirements of QCS Part 05 and be coordinated with design requirements and contract documents coordinated with design requirements and contract documents. Submit complete mix design data for each separate mix to be used on project in a single submittal with at least following information. What demands? Got it. So submit complete mix design data for each separate mix to be used on project in single submittal, and that should be what you say now. What are those? Submit complete mix design data for each separate mix to be used on project in single submittal with at least following information. What should be the information given? Long list of information. Here it is. And it is type of cement. What type of cement is this? Type of cement we have to inform. Then we have to say Portland cement content in that type of cement. Cementitious contents, GGBS, FA, natural pozzolana, risk husk, ash or silica fume. Maximum aggregate size, combined grading curve for coarse aggregate, quantities of all individual materials, so combined grading curve for coarse aggregate, and quantities of all independent individual material, and combined grading curve for coarse aggregate, quantities of all individual materials, then quantities of all individual materials and type of admixture, target slump, type of admixtures, target slump for at discharge per BSEN 123502, initial and final concrete setting time. Initial and final concrete setting time for each mix per STM. You can say initial and final concrete setting time for each mix design per ASTM C403 or equivalent to BSEN standards if specified. Fresh density of concrete per BSEN 12350-6. Then you can say air content has been so we can move further. Then we may say strength grade, hardened concrete, hardened density, you can say hardened density, and water absorption percentage, and water penetration mm if specified. Water cementous material ratio, compressive strength grade, hardened density, water absorption percentage, and water penetration mm if specified. Rapid chloride permeability, column value if specified, and chloride migration. Compressive strength, hardened density, water absorption, and water penetration in mm, and rapid chloride permeability, column value if specified. Chloride migration effect, migration coefficient in meter square per second. Include on delivery ticket as a minimum. These properties must be there. And you may check that if this doesn't comply, how can I accept that? So how many points are there in this? RET 19, 19, 20, 20 points are there. That's the type of cement. So list is type of cement. Again we say what type of cement it is and Portland cement content in this cement, and of course cement content, that is cementitious material, and that is GGBS, Africa, natural pozzolana, Ruskis, ash or silica fumes. Then we can say mix, maximum aggregate size, combined grading curve for coarse aggregate, and quantities of all individual materials. And initial and final concrete setting time for each mix, then fresh ready test, that's for all items. So we can say freshly density of initial and final target slump, you can say initial and final concrete setting time, then fresh density of concrete air content, target temperature, bleeding, chloride and sulfate contents, details of calculated water cementitious material, compressive strength, hardened density, water absorption percentage and water penetration, rapid chloride permeability, that's also important, rapid chloride column value, and then chloride migration effect coefficient, migration right. Chloride migration coefficient. Now include the average deliver ticket as minimum. What's that? Now data shall be from same production facility that we use for this project. Now mixed design data. Mixed design data shall include but not be limited to following, and that is here. Mixed design data shall include but not be limited to following. So we have to understand each point in clear terminology if we just want to control all these. Otherwise, it's only physical work. We do not technical work, not intellectual work, you can say. So mixed design data shall include, but not be limited to following, and that is locations on project. Locations on project where each mixed design is to be used. Here each design we use, that's the location of project. Location of project where each mixed design is to be used, corresponding to structural general notes on drawings. Proportions concrete constituent materials shall be proportion to yield 1 meter cube, that is concrete constituent materials shall be proportion to yield 1 cubic meter. Submit strength test records. Strength test records, mixed designs, materials, conditions and proportions for concrete, used for record of tests. Standard deviation calculation and determination of required average compressive strength. Average compressive strength, if required by engineers. So what you have to submit? Let's say you can say test records, strength test records, and mixed design materials, then conditions and proportions for concrete used for record of tests. Standard deviation calculation and determination of required average compressive strength. Is that? It exists. Yeah, it's there. If early concrete strength, is required, contractor shall submit trial mix. If early concrete strength is required, contractor shall submit trial mixes results as required. Test records to support proposed mixture shall be no more than 12 months old and use current cement and aggregate sources. Test records to establish standards. Deviation may be older if necessary to have acquired number of samples. Test records, then you can see manufacturers' product data for each type of admixture, manufacturers' certificates for that all admixtures used are compatible with either each other. You can say manufacturer certificates data that all admixtures we had to see manufacturer's product data for each type of mixture, manufacturer certification that all admixtures used are compatible with each other, all information indicating compliance. Then we can say manufacturer's product data and data for each type of admixture, manufacturer certifications that all mixtures used are compatible with each other, All information indicating compliance with contact document including method of placement and method of curing. And then we have to say mass concrete or massive concrete. So submit mixed design for mass concrete elements in conformance with requirements of AC 301 section 8. Concrete mix design shall not be with a high RD value. Mass concrete. Let us say mass concrete. Submit mixed design for massive concrete elements in conformance with requirements of ACI 301 section 8. Concrete mixed design shall not be conducted with a high early strength unless otherwise demonstrated by contractor for capability of maintaining proper temperature and approved by engineer. Submit proposed methods of submit mixed design for mass concrete element in conformance with requirement of ACI. Concrete mixed design shall not be worked with a high early strength unless otherwise demonstrated by contractor for capability of maintaining proper temperature and approved by engineer. So low temperature is practically requirement, but if you want to use high strength, you have to do it. You can say, again I say, because it is important, submit mixed design for massive concrete element in conformance with the requirement of code ACI. Concrete mixed design shall not be worked upon with a high RD strength unless otherwise demonstrated by contractor for then we have submit proposed method of temperature control. That's the important point. Submit proposed methods of temperature control, including cementitious material control, cementitious material content control in mixed design to reduce heat generating potential of concrete. Pre-cooling of ingredients to lower concrete temperature as placed and meet impact. Then we can submit analysis of anticipated thermal development within massive concrete elements with proposed mixed design for these elements. Results of analysis using method in ACI 2007-1R and ACI 2007-2R, such as schemmed model and site specific data, shall address maximum differential temperature and maximum temperature during curing. Submit proposed number and allocations of temperature monitoring devices to record temperature development between interior and exterior of mass concrete. We have to include with submittals. You can read them. These are very, very important points for massive concrete, because people are not very much clear about what's the massive concrete, how does it impact, and how it is impacted upon. Now, exposure classes. Exposure classes are related to environmental conditions surrounding concrete in service. We have now exposure classes are related to environmental conditions surrounding concrete in service. Concrete may be subject to more than one of classes described herein, and environmental conditions to which it is subjected need be expressed as a combination of exposure classes. When two or more aggressive characteristics lead to same class, exposure shall be classified into next higher class, unless a special study for specific case proves that it is not necessary. For a given structure, different concrete elements may be subject to different environmental classes. Reinforcement, corrosion, and sulfate classes. Classification system described herein is based on approach in BSEN 206-1, BS 8500-1, and Concrete Society 163. Exposure classes related to reinforcement, corrosion. Exposure classes related to reinforcement, corrosion are associated with carbonation and chlorides. Exposure classes related to reinforcement, corrosion are associated with carbonation and chlorides. So we can say here is table, and exposure classes related to sulfate attack are given in this table, that is in relation to sulfate and pH of groundwater. Sulfate content is SO4 mg per liter. SO4 mg per liter, that shall be determined per BSEN 196-2. pH shall be determined per ISO 4316. Exposure classes for reinforcement corrosion. Exposure class, as we said, X0, 1, 2, 3. No risk of class description is here. In X0, no risk of corrosion or attack, non-saline conditions, blinding concrete, non-reinforced concrete or slab on ground, as we said in that. And mild exposure, as we defined before, that is non-saline conditions, dry or wet, rarely dry, External concrete at least 3 meters above ground level. Internal concrete in dry conditions. Concrete permanently submerged in non-saline water or non-aggressive groundwater. There's class S1, you can say. That is X2, moderate 1, moderate exposure, non-saline conditions, cyclic wet and dry, external reinforced concrete less than 3 meters, external reinforced concrete less than 3 meters above ground level, water gaining structures exposed to fluctuating water levels, and X3 same as aggressive exposure, permanently submerged or wet, really dry, concrete in contact with groundwater, including capillary, rise zone, concrete containing or permanently exposed to saline water. And then X4, severe exposure, moderate humidity, external concrete within 1 kilometer from sea or in contact with high saline water table or subcast concrete not affected by condensation, irrigation or leakage which are more than 3 meters above ground level. X5 is extreme exposure, cyclic wet and dry, extreme external concrete within 1 kilometer from sea or in contact with high saline water or subcast. Concrete affected by condensation, irrigation or leakage, which are less than 3 meters above ground level or within capillary zone. Concrete surfaces exposed to seawater, splash corrosion, and there is sulfate exposure classes. As you have S1 to S5, S1, S2, S3, S4, S5, and that is exposure class. Then the sulfate and magnesium classification, and then natural soil, and of course a brown field. In this sulfate and magnesium, 2:1 water soil, you say 2:1 water level, water soil, 2 is water and 1 is soil. 2 is water, 1 is soil or groundwater. In this case, SO4 milligram per liter, and this also a milligram per liter. In case of this is Mg, shell and magnesium. Shell magnesium. Now here is sulfate exposure classes. In one case it is, that is water, soil, groundwater, SO4 milligram per liter and Mg milligram per liter. In this case, S1 is that where sulfate contents are less than 1500 milligram per liter, and S2 is that where it should be between, that is sulfate content, that sulfate and magnesium content should be between 1500 to 3000, that is class S2. When S3 is, you can see between sulfate contents between 3001 to 6000, and here is magnesium is less than or equal to 1000. We have here S4 class, which is sulfate content greater than 6000 milligram per liter, and magnesium content less than or equal to 1000. S5 is where sulfate content is more than 6000 milligram per liter and magnesium is greater than 1000. Then it's sulfate magnesium was natural soil. In natural soil, static water pH and mobile water pH. So mobility of water is called mobile, and then static water pH is in all these five cases greater than 3.5 static water pH, and here in mobile water is, that is S1, S2, S3 no mobile, and S4 is S4, 5 is, you can see greater. It is not mobile, not mobile, not mobile in three cases. Then fourth is greater than 5.5, S5 is greater than 5.5, and here brownfield, that we can say that is brownfield. Brownfield are those previously occupied and contain chemical residues into ground or groundwater. So that is brownfield. You can say not new project. Static water pH is greater than 5.5 in all these five cases, and mobile water pH is in first three cases not mobile, and then in 4 and 5 it is greater than. Are those previously occupied and contain chemical residues into ground or groundwater. Mobility of water shall be determined. We have here we have, I already crossed, I have to cross 2 hours only, not more. I don't have more than that today. So let's see for a couple of minutes more. Fresh concrete. Its journal is where adequate workability is difficult to obtain at maximum water cementitious ratio allowed, where adequate workability is difficult to obtain at maximum water cementitious ratio allowed, use of plasticizers or water reducing mixtures may be considered. Alternatively, an increase in cementitious content may be considered, where this shall not adversely affect durability of concrete. So it is very, very clear, where adequate workability is difficult to obtain at maximum water cementitious ratio allowed, use of plasticizers or water reducing mixtures may be considered. Alternatively, an increase in cementitious material, cementitious content may be considered, where this does not adversely affect durability of concrete. Cementitious contents in excess of 400 kg per cubic meter shall not be used unless a special investigation or special consideration has been given to effect for heat of hydration and reduce thermal stresses in concrete. So what I say, you can say cementitious concrete in excess of 400 kg per cubic meter shall not be used unless a special consideration has been given to effect for heat of hydration and reduce thermal stress in concrete. An approval has been obtained from engineer. Maximum cementitious content shall not exceed 500 kg per cubic meter. Proportioning, mixing and placing of mixture shall be conducted in accordance with part 7 edit of this section. Temperature shall not exceed 32 degrees Celsius unless construction testing to verify a proposed concrete mixture shall function satisfactorily at a concrete temperature greater than 32 degrees Celsius. No concrete shall be placed if concrete temperature is above 35 degrees Celsius. For massive concrete, concrete producer shall demonstrate the temperature of concrete due to hydration comply with maximum fresh concrete temperature specified. Supplier may use in its demonstration testing heat sensors and simulation technologies which measure concrete heat of hydration and its rate versus concrete curing age. Contractor is responsible for ensuring that concrete is able to be fully compacted within concrete element regardless of reinforcing density or other limitations. This may involve reducing maximum aggregate size, increase level of concrete workability, or use self-compacting concrete. Where consistency of concrete is to be determined, it shall be measured either by means of slump test conformance or flow table test conformance. Consistency of concrete shall be determined at time of use of concrete or in case of ready-mix concrete at time of delivery. The tolerances for different consistency tests and target values are in this table. Tolerances for target values of consistence, that is slump and flow meter. Slump is for smooth samples taken from initial discharge, and that is slump. Target value and tolerance. Target value is less than equal to 40, or you can say tolerance is plus minus 30 plus 40, so less than equal to 40, 50 to 19, and greater than 100. Same way slump tolerance is minus 30 plus 40, minus 40 plus 40 for 50, and minus 50 plus 60. Target value is flow meter in this case. This is so you can say here flow meter is target value all values, and tolerance is minus 60 plus 70. We have spot taken sample is this, and other one is flow meter, flow diameter. Grades of concrete. What are grades of concrete? Where strength is classified with respect to compressive strength. This table gives concrete grade with requirements for water cement ratio and cementitious content. Characteristic compressive strength at 28 days of 150 mm cubes and FCK cube or 150 mm diameter by 300 mm cylinders. FCK CYL may be used for classification. Exception will be made for concrete mixtures containing fly ash, silica fumes, or GGBS, where testing shall be requested at 56 days or 90 days as approved by engineer. So it is little double. Exception be made for concrete mixtures containing fly ash, silica fumes, or GGBS, where testing shall be requested by then concrete grades and completion requirements. We'll see 15, 20, 25, 30, 35, 40, 45, 50 phases. All this we'll see. And density requirement will take for this, and we can say we've gone through this concrete specification to some extent, not to whole, but we have to go it slow and understand concrete, because without concrete we cannot achieve quality, and quality is really very important. We have to be very serious about that issue. Very seriousness is required in this, and we cannot do that, so we can't do anything. And that's where point lies in. course, we think we'll take care of this at later stage, as it's slow specification. It should be clear, though this is not perfect specification, I can say. Even in massive concrete block, it has not given exactly temperature controls to full extent. Only ordinary temperature of 32 degrees is given. But in fact, in massive block, we can say where temperature is very important factor, that is not 32 degrees, we have to control it below 24 degrees. Of course, the lower range is same, 5 degrees or 4 degrees Celsius. So maybe it is not complete studies even in this specifications, no problem. It is practical. I have done it up to 24 degrees, and where you can say there's no other way but to use supplementary cementing materials or cementitious methods, if we call them, like GGBS, particularly where we use GGBS, not even FPA, use GGBS or microsilica, and generally because microsilica is very expensive, GGBS is used for this purpose. And that's of course very important point we have to take into consideration, and we cannot move without that. It's based on experience. Maybe this person who drafted, who designed this specification at international level, not having exposure practically, and that's why this point has been missed. No problem. It's only for purpose of communication. If points are missed, this can be corrected, and we can write that in method statements, because it has been said that manufacturer of concrete, or you can say batching plant, has to demonstrate about controls. So it is in our hands. It's in our hands, and this is not rigidity direction. This is direction, suggestive one. We can conduct experiments, and we can do whatever is adequately, whatever is to be required, that we can do. So I think we have gone through some concrete work in this of title Civil Field Engineering, like Engineers+Concrete specs, quality, and of course this AnnexSL quality system. And this is all part of quality system, that we have to go through specifications, we have to create specifications, we have to work on research of specifications, we have to review them. And of course contractors are related. It may be white, it may be red, it may be silver. Everyone is related. So this is method also, you can say, part of design as well as construction and contracts, all that. And of course disputes are generated out of these. And this is, you can say, complete communication coordination system we are talking of. And I think with that I take this off today. We have to concentrate on this. We have to move further. This is page, I remember, I don't know how much pages, 44 I think. This is page 44 of this specification. So we will continue next time. Today a little other work to do. I hope. Thank you very much.